Let us take up a recursively defined sequence that is defined by this rule that the first term is 2 and each subsequent term determines on the previous term by this relationship. So how would the sequence progress? The first term is 2 and the second term is 1/2 2 plus 4, that is 2 plus 4, that is 3. The third term would be 1/2, then 3 plus 4. That is, what I did was, for an, I wrote the previous term here, which will be 3.5, and so on and so forth. Or in other words, we have 2, right? 3, 3.5, and then just going on like this. So what we are going to do now is that we are going to see that how to describe this sequence by using the spreadsheet Excel. Okay. So let's write the value of the first term here. And then for the second term, you see the second term will directly depend on the first term in the following manner, that we have 1/2 times the first term plus 4. Then in the second one, or in the third term, we have 1/2 times the second term plus 4. Then for the third term, we have 1/2 times so for the fourth term, we have 1/2 times the third term plus 4. Okay. And now we can just do this here, select all these and pick this lower right corner and just drag it down. And you can see you get the subsequent terms of the sequence, and this sequence converges to 4. Okay, and you can use the monotone convergence theorem to prove that this sequence, being a monotonically increasing sequence with least upper bound equal to 4, does converge to 4. Okay, so let's take just one more example. So let's take up this sequence, famously known as the Fibonacci sequence. Okay, so the first term is 1. Okay, let me just put that in the center. The first term is 1. The second term is again 1. And then from the third term onwards, how do we go? We just add the first 2 terms, right? Or the previous 2 terms, I'm sorry. So I did this. Then for the third term, what I would do is that I'm going to just add the second and the third term. Then for the fifth term, I'm going to add third and the fourth term, and that's how it progresses. And of course, you will see that this is a sequence that just diverges very fast, right? Now next, let's look at what is called the sequence of Fibonacci ratios. So the sequence of Fibonacci ratios are defined by taking the ratios of the Fibonacci sequence in the following manner. That is, we start here, and what we do is that we take the ratio of the term with the previous term, starting with the term 2. Okay, let me place this again in the center. Okay, so here what we would do, we will take the ratio of this term with the previous term, and that will be a 2. And then again, going in the same manner, we are going to take the ratio of the first term and that of the third term. And if you just drag it down, you will see that this gives you that this sequence, first of all, the Fibonacci ratios converge, and they converge to what is called golden ratio, that you can obtain by proving that the ratios converge to 1 plus square root of 5 over 2, which is approximately 1.618 that we saw by an inductive process. Okay.